This video is going to cover 4.4 for statistics, and we're going to talk about contingency tables. So a contingency table, also known as a two-way table, just relates two categories of data. Two categories of data. So if we look down here, we're relating education level with work, whether they're employed, unemployed, or never have been employed. So that's a contingency table. We're comparing those two types of data. In a table, the row is horizontal, columns are vertical, and then the cell is just each box. So this is a row, this is a column, this is a cell. Just in case I talk about things in the future. A marginal distribution shows the frequency or the relative frequency. You can have a relative frequency distribution for either a row or column. So here, essentially, the frequency is going to be our totals of our rows or columns. So we would just add across this plus this plus this plus this. If I add those up, I get 128,744. If I add the unemployed numbers, if I add those up, I get 6,395. If I add the never worked numbers up, I get 73,581. So there's our row totals. And then we can do the column totals as well. Add the sum high school. I get 24,395. Add the high school. I get 61,442. Add some college. I get 54,319. And add the degrees. I get 68,564. And then if I add that whole column or that whole total, it's really showing that I have 208,720 people represented. So if I add all of these boxes, I get 208,720. So that's our marginal frequency. Then if I did marginal relative frequency, we're going to take the total of that row and divide by the total to get our percent. So here I would do, this one. For this box, I would do 128,744 divided by the blue total, 208,720, and I get 0.6168. Then I would do the same thing, 6,395 divided by 208,720, 0.0306. And then 73,581 divided by 208,720, and I get 0.3525. And then we do the same thing here. We're just going to take this total divided by 208,720, and I would get 208,720, 0.1169. 0.2944, 0.2602, and 0.4, oh, I forgot a number, 68564. That makes much more sense. 0.3285. So the purple is our marginal distribution. The yellow is the marginal relative frequency distribution. It's just the percents instead of the totals. A conditional distribution goes one step further, and it lists the relative frequency for each cell by a specific variable. So we're either going to divide them all by the total of high school of education, or we're going to divide them all by the total of work. So conditional by education means divide every cell total by the education total. So if we compare up here, our employed total was 10,179. And we're going to divide that by the education total, which is this 24,395. So we do that division, and we get 0.417. And I didn't go to the 4 decimal places, but there we go. So 0.417. Let me get the fourth one. 10179. 3. And then for this box, we would do 945 divided by 24,395. And we would get 0.387. And then the no work would be 13,271 divided by 24,395. And we would get 0.5440. If we did the total, we would just end up doing 24,395 divided by 24,395, and we'd get 1, because 100% would go there. So that's how you fill this out. Pause the video, see if you can fill out the rest of this on your own, and then come back and check. All right, I'm just going to save room here. So this was 0.4173, 0387, 5440. And then if we kept going for this column, we're going to divide everything by 61,442. So we would get 5472. 0327. And 4200. This whole column we would divide by 54,319. And the reason I'm going to 4 decimal places is just like we said from 4-2, unless otherwise specified, that is a good rule of thumb for what to round to in statistics. 36. Remember to round up when you need to. Okay, 17,089. Oops. 4, 6. And then the last column we would divide by 68,564. And oops, 0.2540. All right, so those are the relative frequencies. So now we have our conditional by education, because we divided by the education totals. These would all be 1. Now, using that table, we're going to answer what proportion of the following groups of individuals is employed. So we're only looking on our employed row. Those who didn't finish high school. So only some high school and employed would be 0.4173. Then high school graduates. So we're looking at high school graduates that are employed, 0.5472. Then some college, so 0.6518. And then a degree would be 0.7224. So describe what you see. Well, these numbers go up. So as education increases, it looks like employment increases. Now let's look at the no employment. What happens with the unemployed? So currently working but never working. 0.38, 0.32, 0.33. So that looks like it's going down. So as the education increases, unemployment decreases. That makes sense. If your employment's going up, your unemployment would go down. And then never worked. Let's look at those. So we've got 0.54, 0.42, and again, those are going down. So as education increases, never working decreases. So all of those things fit. That's all you're doing is you're just describing positive, negative, up or down. Then, if we wanted to turn that into a bar graph, the easiest way to do it is to just make one section for each of these and then draw your bars. So let's see, our highest number is 0.72. So I'm just going to make a graph. Let's go 0.1, 0.2, 0.3. And I just pick something that might be easy. And then down at the bottom, so we're going to have some high school. We're going to have a high school diploma. We're going to have some college. And then we had a degree. Those were the things on the top. Then, oh, that's not what I wanted to do. Then down the side, we have employed, unemployed, and no work. So, let's see. Employed, unemployed, never worked. Employed, unemployed, never worked. And then we would just do 3 bars in each of those sections. So, employed was 0.41, 0.54. So this one go to 0.41, and then 0.54, and then 0.65, 0.72. So something like that. Not perfect, but shows that it's going up. Now let's do the next row, unemployed. 0.038, 0.032. So 0.038, 0.032. 03, I lied. 0.038, 0.032, 0.033, and 0.0236. So that's really hard in there because they're all like way down below. And then let's do never employed. So 0.54, 0.42, 0.54, 0.42, 0.31, and 0.25. So quickly sketched one. This shows the blue is really hard to see on this scale, but you can see that the red goes up like we said it did here. Purple goes down like we said it did here. And like I said, it's hard to see that one in the middle. But that's a conditional bar graph. It's just showing you each section separately. We're saying, hey, this is that relationship, this is that relationship, this is that relationship, and then you compare each one individually or across the 4. That is section 4.4. Let me know if you have any questions.